Okay, folks, welcome in. This is our, sorry about that. This is our lecture. Come down to here. This is our Design 300 lecture. It's Tuesday, November 9th at 10 o'clock, and we are on Google Meet. And please remember that next week, oops, that one's on the wrong one. I forgot to change the color of that one. There we go. Please remember that the 11th is a holiday. It's the Veterans Day holiday, and it's a good opportunity to express your appreciation for the service that's been provided to us by members of our armed forces. So 11th is the holiday. So this is our information for this week. And that can go away. There we go. And so let's take a look. We're doing energy analysis this week. And you can see this work on eQuest and Revit if you'd like to try it on your own. But there's no reason to. We'll just be demonstrating. But if you'd like to, this is really, to me, this is super interesting stuff. So eQuest and Revit are both excellent tools for what you're going to find out is called BEM, Building Energy Modeling. So there will be the recording for you to look at, a playlist, which will basically just be this recording, and our energy analysis material to read. And then there's some primary resources that I'd ask you to read too. Okay, and these are links from this other one, but this is really a great site, and it's energy.gov, so it's one that we can pretty much rely on as being well-founded and in compliance with all regulations. And the U.S. Department of Energy has a big stake in this. So those are all big dogs in the industry, and they're very important that we follow the rules and regulations that are set up by them. Okay, your discussion posting is to compare some energy calculations. So I'm going to talk about that now so you can be thinking ahead as you're watching the recording. Actually, I've got it open already. Here's a very interesting way of figuring things out. It's some very fun math that comes out all wrong. But folks do figure out things in different ways, and they do it differently. Hopefully not as badly as what you see here. And so I was really trained in my engineering professional career to try to solve problems many different ways. And if I get the same good result using 2 or 3 different methods, I've got a really good feeling that that what I've done is going to be right, it's going to be safe, it's going to be proper and appropriate. So look, here's 2 energy calculations. Here's one from eQuest, and here's one from Revit. And they're in the same kind of format. This one's just the kilowatts, electricity. And so you want to look at these and go, compare those answers. And you might use a Venn diagram or just a description or a chart. But you'll be able to do a comparison, state where they are the same and where they are different. Okay, they are the same in that they are the same because I can see these things look alike and then explain the differences. But I note the difference is, and this one is different because, so you want to say same and different. I don't want a description of what they are, although you'll have to do a little bit of that. I want to know how they're the same and different. And Venn diagrams are great. If you haven't done one of those, maybe I'll post something on it. And then there are differences, and so I'd like you to figure out at least one reason for one of the differences and post your results. Now, there's many, many reasons why they might be different. So hopefully you'll be posting a reason that has not already been posted. Okay, so as we go through these, think about this a little bit, because I'm going to do a demonstration in the last half of the class. So let's take a look now at what you're going to be required to turn in. Visualizations of your work. Now, the 11th is a holiday, so we're expecting that you will not schedule work then, that you will take that opportunity to celebrate the holiday in the most appropriate way that you deem fit. Maybe you think holidays are just a great way to catch up on work. I know I've thought that many times in my career, but I would encourage you to actually make it a holiday. We need those breaks, and it's the first break that we've had since almost the beginning of the semester. We have one more break at Thanksgiving and then finals, so this is a good time to catch a little break, especially if you can get your work done in these 3 days and have this time frame free. Okay, so this whole week is an energy analysis, which we're calling BEM, Building Energy Modeling. Some people call it Whole Building Energy Modeling, but WeBEM doesn't sound as good as BEM. And it is applicable in architecture, so I want you to look through and see how it is used in architecture. In HVAC, design and operation. Now, some people include this HVAC in architecture, but they're separated for the purposes of this. Building performance rating. Now, that is a somewhat new thing that's come about since modeling has been available. You can rate a building now and then test it against that rating. And then you can enforce deficiencies. So that's a new thing. In California, it really started with Cal Green, part of the Title 24 Building Code, which I believe was accepted in about 2008. It was really pushed and made real by Governor Schwarzenegger, and it's a very powerful performance-based building code. So that's kind of cool, and it's constantly being updated, which is really good. Building stock analysis. You'll have to read about that and find out what that means. It's not obvious what we talk about when we're talking about building stock. Are we talking about buying stock in a building? How many buildings are available? How much of a building is available for use? So we want to know what that means, and you'll be able to look it up. So 1, 2, 3, 4 items to bring up. Now, where are you going to get that information? It's really mostly from this one right here. So BEM, this is a Swiss Army knife, which is supposed to signify that this is, precision, and there's a tool for every need. And these are some of the needs: architectural design, asset rating, code compliance, predictive control, retrofit, financial incentive policy, all of these things. LEED, that's Leaders in Energy and Education Development. They have a rating system for buildings. So there are all these different uses for the BEM tool. Okay, whole building energy modeling. And you can read about it. And here's the thing, it's physics based. Okay, we actually have good data. We know how much energy a wall can soak up and how much it can put out, and we know how much air can blow and how much heat transfer can take place. We know a lot about buildings based on their geometry. What shape are they? It has an effect. What materials did you use to construct it? The lighting, it has a big deal. HVAC, heating, ventilation, and air conditioning. Refrigeration is a little bit different. That's keeping product and things cold. Not just air. Water heating, renewable generation systems configuration. Thing like power return from heating. It's wind, it's solar, it's all of these things. Component efficiencies, control strategies. They have left off things like landscaping. They include geometry, but it's really building positioning. It has a huge amount to do with your weather pattern. And so this has left a few things off, but that's a pretty good basis there. And we use it start to finish. If you wait till the end, you're gonna have design questions and problems that are hard to take care of because other things that have happened that get in the way. Whereas if you could have thought about it at the start, it would be much easier to make a good decision. Okay, so that's what whole building energy modeling is. There are some tools which are whole building modeling tools. Two of them that we use in our program, and they're available on the VM portal, are Revit, that you'll see here. We've been using Revit, and eQuest. Now, here's a really powerful one. It's no longer really used that much because they've integrated all of this stuff into other programs, and they've made the program even more powerful and predictive. But the new versions are more complex than what we want to deal with at an introductory level. So we're very happy to keep using the eQuest system as a learning tool. You won't be seeing this used too much in industry as a final design tool. But for us, it works out just fine to get certain ideas across. Okay, so we've got all that kind of stuff available to us, Revit and eQuest, and this is a typical eQuest output, and this is a typical eQuest building model. And you have a lot of control over it. One of the difficulties with eQuest is you can't import a completed architectural design. You have to essentially rebuild it in eQuest, and it doesn't export to other building models. So it's sort of standalone. Revit, the newest version of eQuest, is included in Revit. And so it's a little bit easier to work with now. However, you have to get a lot of building design done, and this is not a building design class, so we're just going to play around with it. So those are BEM tools, Building Energy Modeling tools, and I'm going to show them to you a little bit. We have some other tools though, that are useful for a specific portion of the calculation. If you want to know, okay, well, I just want to change this one part of it, how is that going to affect things? Rather than making the change on your entire model, which isn't too hard in Revit or eQuest, but it can be difficult. So if you want to just find out, like we did last week, what does a cool roof do? Is it worth it? Is it worthwhile trying to put that into my design? And you can make those quick calculations based on a rough estimate. And then there's a very cool one called PV Watts, Photovoltaic Watts calculator, that has been also continually updated. I'd say in the last 3 years, it's been through a massive redo because of the increased capabilities of batteries and storage. And so you can find out how much total energy, kilowatt hours, in each year. So kilowatt is power, how fast you're using energy, times how long you're using energy. Kilowatt times hours gives you total energy. And that's what we're seeing up here, total energy. Okay, so you can use a lot of energy for a very short period of time, or you can use a small amount of energy for a long period of time and get the same number. Okay, so those are things that are available to you, and I'd like you to click on them and see if you can find them and make them work and just investigate them a little bit. This is really your chance to learn how to delve in and do research on what is a very important topic. Energy use is a huge factor in our lives these days. It affects energy prices. It affects what's available and when. And as we absolutely know, as a point of fact, it has a huge effect on our current climate and our climate moving forward. So energy calculation is a very, very important part. And the materials that are used are important. Now, I'll show you in a little while that sometimes you think you're going to do something really cool and you use a very special material that everybody tells you is really good for the climate and this and that and the other thing. And you can actually determine what energy use has been saved. Okay? And one of the, I'm just going to throw this out there, it's not in this presentation. There's 2 ways that all of the sustainability and energy people agree will always be in the top ways of having a sustainable, low energy design. The first one is use less stuff. If you can make a building serve its function with 1,000 square feet instead of 2,000 square feet, that's using less stuff, and it will be better for the environment to build a 1,000 square foot building than a 2,000 square foot building in general. The other one is to what they call upcycle a building, not recycle. That means you tear it down and send the parts off to their constituent recycling places. Upcycle is you modify it for a new use. And usually, even though the materials might not be as good and might have a little bit more of an energy footprint on the building when it's done, the amount of energy it takes to create or harvest or transport or build a new facility is huge in comparison. So, upcycling is another big word when you're talking about sustainability. And we're going to talk about that. And your energy analysis is key to understanding whether your sustainability, your upcycling, your recycling, your choice of building materials is worthwhile or valid. It's very complex, super complex. And these analysis tools are allowing us to understand the ramifications of our choices. Okay, so let's take a look then. If you click on the whole building energy model, and you'll see, I'm going to go through this a little bit quick because I want to see some stuff. Here's a cool thing, EERE, energy efficiency and renewable energy. So you can find all about this stuff, initiatives in progress, success stories. This is a really good place to go and start just looking about how does all this work, energy efficiency and renewable energy. But here's your main description and what BEM is. Here's where you get your information for your submittal. How is it used in architecture and design? And I'm hoping you'll do more than just read this little bit, but you'll go to the new tab, and you can go from new tab to new tab to new tab. Look, there's always cool stuff to read about, more things. What is ROI? What is the 2030 commitment? What is Open Studio? What is Energy Plus? Energy Plus is what has been integrated into Revit. So you can look at all of this. Oh my gosh. There's just a ton of information in here to look at and sort of pare down into one thing that you'll do here. But you should be able to follow 2 or 3 or 4 links at least and put some interesting images in here for architecture. Now let's look at HVAC, design and operations. Again, you can open a new link, and it's very much the same. Selection, sizing, hybrids, control strategies. HVAC is an amazingly cool, complex area of work. It wasn't my main thing when I was in industry. I was more of a pump person, but my systems always interacted and were coordinated with the HVAC systems. So I'm not a pro, but I understand the terminology and the importance and how things get done. And I've made it a point to learn more. So these are, this is what's called a building schematic, a control schematic, system design, zone design, real-time BEM, which they used to call SCADA, but they're changing the name. So SCADA was supervisory control and data acquisition. And so now they're calling it real-time building energy modeling. This is like, wow, really, really cool stuff. Super techy, really fun. These are great resources, and you're going to find that, again, it's not going to talk about materials as much as it is about schematics and things like that. But all of these roll up to your final material analysis. Building information and rating, inherent performance, and these code compliance, green certifications, and financial incentives. That's part of the compliance enforcement, for example, in Cal Green. And sometimes designers are given financial incentives in their design if they meet certain goals. So let's take a look at that page. So this is where you're going to go for each page. That last one we just did was HVAC. Now we're on performance rating. Comparing buildings, energy asset score, Energy Star, commercial building energy consumption survey. That's something that gets done. You want to be more up here as an example, right? You'd rather not be down here. PG&E sends these out. They do them very poorly, but they send you out a building comparison energy score. Probably SMUD does too. So these, the problem with PG&E is they don't actually take good data. They just look at some old stuff. But you can, if you've ever looked at a PG&E or a SMUD bill, you'll probably see stuff that compares you to similar buildings. So this is really cool stuff, and it is good. And, do you need to use an automated system or whatever? Okay, it's all being done now. We had a team of interns in the Design Hub that went to work for a local HVAC control startup in the McClellan startup site, and they were using localized AI with Raspberry Pis, which is a tiny little electronic computer, basically as a controller, to create an AI learning system for buildings that they installed in the HVAC systems so that it would learn to operate itself better. So, for instance, if it saw one portion of the building would get a lot of use a little bit early, and you could warm up that building slowly a little bit beforehand in that area, then you wouldn't have such a shock load and you'd have better energy performance. Or if it saw that there was very little occupancy in a building at a certain time, it would instead of waiting for the CO2 levels or the heat levels or the inherent heat loads to go up or down, it would do it predictively. And they immediately enrolled like 1 million square feet of businesses. And so our interns were helping them create new interfaces, programming interfaces for that. And it's a very good small company now. And so this is a big, big, big deal. Huge amount of work going into the present is automated, and it's all working off of BEM. And I know that people are spending a little bit of extra money up front. They put in some extra electronics. They put in what are called variable air valves instead of just plain old registers. And overall, long term, it saves a lot of energy in the building. Okay, so the last one we want to look at is building stock analysis. Okay, so this is you know, what works and what doesn't work. Do you need more R? Do you need less R? Do you want to put more into your heating system or more into this? And so this is basic performance that says, okay, well, this is going to be sort of, you can see all these different versions. And what you do is you pick an area where you want to perform. So this is really cool stuff. And it gets really complex. So if you're a person that likes predictive modeling and graphs and maybe generative design, these are all done by what they call generative design, where you give it different ideas and levels and things that you can do, and it starts picking and choosing, and it just cranks out a ton of data, and it creates different designs for you. And then you can pick and choose what your yes range is. Really cool. Really, really cool stuff. And so you can, this is your minimize carbon. And right, so if you want to minimize carbon, you're going to get this one, but it's going to cost a little bit more. And this is probably minimize cost. Oh, maximize lead. Okay, get your best overall lead certification. And so you can give it different ideas and concepts. This is just really the coolest stuff you can think of. And so if you're more into the calculation and analysis and using some energy modeling and simulations and maybe some AI, this is really a cool area for you to maybe start looking at. And there are some more in-depth classes in this with our friends over at Sac City in the mechanical HVAC design program, where you can focus on just this kind of stuff a little bit. But this is really, really neat. Mostly you'll get engineers asking the designers to create these models, and the engineers are developing the metrics that will get used in it. Okay, so there we go. There's some cool stuff for you to review and look at as you go through these 4 slides and get yourself ready. So now let's take a look. I'm going to show you eQuest. And I'm gonna talk about the output first, and then I'm gonna show you how we get it. So this is a typical output from eQuest of a building. Let me show you the building. There's a building, and I just chose some building, and I can design the building. I can do some energy efficiency things. I can simulate the performance. Let me do that. Click. And it's looking it just ran through every day of the year and found out how much energy would be used. And it gives me this. And it says in January, I used a certain amount of energy, blah, 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 blah. And this is a commercial building in Sacramento. And you can see there's no space heating. Because in the commercial buildings, all the lighting and just regular stuff. Sorry about that. And just the regular stuff creates enough energy to heat the place the way this one is designed. But there's definitely equipment and cooling and lighting and some water heating. And you see it's going to take 15,000 kilowatt hours. Well, let's take a look here. That's going to be 15,000. So it's 15 times 1,000 times how much does a kilowatt hour cost? Well, in the SMUD area, depends commercially, maybe averaging 0.25. So that's going to cost you $3,750 to do this building. Well, it's a 25,000 square foot building. But that's how you would use this. And then you would say, shoot, that's a lot of money. I want to save some money. So you might look at ways to reduce your lighting costs, because that's a big chunk. Maybe you could put in LEDs or this, or change how the lighting is turned on or off, or go to task lighting. Maybe the miscellaneous equipment, that's all your computers and your copy machines and your coffee makers, and maybe you have some laser cutters or things like that. So maybe you can make those more efficient also. But you look at what you're using a lot of, wouldn't do much to try to get rid of this little ventilation and fans. Even if you made a 50% difference, you wouldn't change much. So this is how we use it. Now, if I go back to my building mode, you're going to see that, well, first of all, there's tons of stuff to put in. There are 41 pages of input to do the whole building energy analysis. Man alive, that is a lot. So I could maybe change my zones. I could maybe change the shape. I could change how tall the floor to floor is and put in more insulation. But here's where I really get to do it. I could maybe do additional rad barriers. Maybe I want to do over a conditioned space with some interior insulation and some cap and finish. And my metal grade, instead of being plywood, I'll do CMU. That's usually much better. I'll put on some board insulation. Slab penetrates the wall. So these are all things that you can do while you're building the design. Okay, maybe I'll put carpet down with a rubber pad. Maybe I'll put a concrete cap on. maybe I'll do some rigid insulation. All of these things, I can change the windows. Let's say I'm going to go with, I'll go with a double low E. And aluminum without break. Maybe I'll make it fixed with an insulation. So I can just start doing all this stuff. Oh my gosh, I can change the amount of energy I'm using in certain areas. I can change when they're being used. I can change the efficiency of my system. An EER of 8.5 is crummy. Change it to 9.5. And the COP, let me change it to 3.2. Those are all really crummy numbers that I'm changing. So my building looks exactly the same now. And I've got to resimulate. And it made a little bit of difference. You can see I've got just a little bit of difference. I could come down here and look at my other one and find my total. I could find my total. Okay, and see what happened there. Okay, so I could go and I can just look at these and see what I've done. So that is what eQuest is like. Now let's look at Revit. You'll see it looks very much the same. We've got interior lights, interior equipment. You'll notice that because of the way this model is set up, I don't have any heating or cooling. I have interior lights and interior equipment. I have interior lights and interior equipment. So I'm missing a big chunk of this. Okay? So that's something to be aware of right off the bat. Okay? And so I'm missing a lot of stuff in here. It's still, but my numbers are low. That's like 4.3 thousand. So they're all under 4,000. So you'd want to know, why might that be different? Well, it's different because I haven't really built a building. I just put up 2 zones. There's no interior zone, no perimeter zone. I don't even know what kind of walls I've got here. I don't know much about this building. It is about the same size, but there's no HVAC. There's no lighting put in. So even though there's lighting, there's no actual real stuff put in. I don't know what's in these spaces. They're just analytical spaces. So it did do stuff for me analytically, but it doesn't have any real building design in there to tell us what's going on. So it's the equivalent of only having I'll get there, like some information here that you don't even know what they've put in. Okay? We don't know. It could all be at, 0.5 or 0.6 until we actually put it in. Now, I could go back and do that, but I didn't feel like it because, we're just not doing that much here. I'm just trying to show you some things. But when you start talking about differences, you want to look critically at what are some of these things and what's included in the Revit one and the eQuest that are not included in the other. And then think if there are other things. Maybe they're using a different standard year. Maybe they're using different windows. This one's actually using more. So I'm going to suspect that this design is more developed and there are more sources of energy use in the eQuest than we've bothered to model into here because there's nothing in here. There's no HVAC system. There's no lighting system. There's no pump system. There's really nothing in here to start making stuff go. Okay? But I wanted to show you how they work. And then this has a bunch of extra cool information. Here's your total energy per square foot. That's a big important number because compliance wise, you can't really tell somebody, well, you need to use this so much energy because you don't know how big the building is. But energy per square foot can be standardized for different uses. And so that's really cool. This is how they turned everything into that number called kilowatt hours and BTU. Okay, so everything got turned into BTU. Kilowatt hours, all these things got turned into BTU somehow. And then these are all, so it looks very much the same. It's just a little bit different. And this can get exported. Well, I know I can export this. They change this all the time to figure out how to do it. There we go. It's really just copy paste and put it into your own set of spreadsheets. But look at all this data. And oh my gosh, look at all this stuff here. Okay, so this is a really great report, and it just happens. It doesn't just happen. You got to do stuff in this energy optimization. But this is a really, really nice tool that's available in Revit. We've been kind of focusing on Revit. You do not have to use Revit for this week. I'm just showing you what it's like. But you're going to probably touch Revit in almost every class in design technology. And so it's good to touch it and see what's available. It is, in construction and architectural design, the main program that's used certainly in the western United States, much of the eastern United States. There's a few places that still use others, but mostly people have gone to Revit, and you can see why. You know, I can get framing loads, I can get energy loads, I can get engineering loads, I can get piping loads, I can get electrical loads, I can get tons of interesting stuff out of my model. And so this BIM, Building Information Model, feeds a BEM. And now they have input. Somewhere I read in here, this new one, that they're using see, there it is, Building Energy Model. I read somewhere that they're using that new Department of Energy, Energy Plus. Okay, and so then I can also look only at my HVAC but I don't really have a good system put in here yet. Okay, so there we go. That's what we've got to go over for this week. I'm going to go ahead and stop the recording, and I'll get this posted shortly. Please remember that Thursday is a holiday, and that we're hoping that you actually take the opportunity to honor our veterans and our current service members, whether they're currently serving or have in the past, and show appreciation for the service that they've rendered to us. Okay, thanks a lot, folks. I'll see you next week, and I'll look forward to seeing more of your good work when you turn it in.